What if I told you that JavaScript developers are becoming the new architects of artificial intelligence? Welcome to JSEngineer.ai. My name is John, and here we don't just talk about AI, we build real artificial intelligence using JavaScript. For the last decade, AI was synonymous with Python. If you weren't using Jupyter notebooks, PyTorch, or NumPy, you weren't invited to the party. It felt like a private club where only data scientists were allowed to play. But a massive change has occurred. We have moved from the era of training models, which is still the domain of researchers, to the era of building with models. And guess what? The challenge of building latency, real time, complex state, and creating beautiful user interfaces are not Python problems. Those are JavaScript problems. As a full stack developer, you are actually better equipped to build the application layer of AI than a data scientist is. And this is important. Modern AI is no longer just about models, it is about systems. And when you look at the size of the JavaScript ecosystem, it's impossible to ignore. It's not just OpenAI anymore. We have first class SDKs for Anthropic, Google Gemini, and Amazon Bedrock. For agents and automation, we have an incredible stack from Launcher.js or AI SDK to background job platforms like Trigger.dev and durable execution with AWS Lambda. The data layer, fully covered. Vector database like Pinecone, Kudron, and pgvector integrate seamlessly into JavaScript application. And we even dominate the media layer, whether you are building agents that make and receive phone calls using Buppy and Twilio, or generating lifelike speech with 11 Labs or Cartesia, or running open source model through Replicate. It's all available in JavaScript. And here is the real superpower. We can run models locally in the browser using transformers.js. That means near zero latency and zero server costs. Alright, enough theory. In this video, we are going to build the hello world of AI engineering with JavaScript, generating a simple test response. But first, we will do it the traditional way by calling LLMs directly through HTTP endpoints using fetch. We will connect to 4 different providers: OpenAI, Anthropic, Google Gemini, and OpenRouter to run an open source Llama model. Let's start with OpenAI. I'm running nps tsx fetch directly / openai.ts just to run this file. First, look at the endpoint. We are calling OpenAI Response API, and the URL is hard-coded directly into our code. Next, the headers. We manually define the content type and we pass the API key using the authorization header. Now the request body. OpenAI expects a very specific schema, a model field and an input field containing the prompt. So far, so good. Now let's look at the response. The response comes back as an output array, and the text we actually want is deeply nested inside it. To extract it, we have to find the object where type is equal to message. Then, find the content where type is equal to output text. And finally, read the .text property. It works, but notice something important. Every part of this code is tightly coupled to OpenAI. Let's see what happens when we change provider. Now, let's switch to Anthropic's cloud. First, the endpoint. Completely different URL. This time, we are calling version 1/message. The headers are different too. We need an add API key and a mandatory Anthropic version header. Now, the body. There's no input field here. Instead, we send a message array with roles and content, and we must specify match tokens. And now the response. Cloud returns a structure that looks nothing like OpenAI. No output array, different nesting, which means if we want just the test, we need brand new parsing logic. Now let's switch again to Gemini. Look at this. This is a new endpoint, new authentication headers. Here we have an additional header with name ets goog ets API dash key, and the request body change again. We have contents, it's an array. We have parse, we have test. And once again, the response format is completely different. Same task for generate test. 3 providers, 3 endpoints, 3 requests, schema, and 3 incompatible response formats. Let's look at one more provider, OpenRouter. I'm running npx tsx fetch directly slash openrouter.ts. The endpoint changed again. Now we are using a chat completions style API. The headers go back. We have again authorization header, but the model naming convention is completely different. We are calling Llama open source model. We are sending message again, but the shape is not the same as clouds. Yet another structure similar to chat completions, but still different from OpenAI response, different from cloud and different from Gemini. And look at the response. We have choices here. We don't have output or candidates. The response is again different. So now in a single project, we already have 4 different endpoints, 4 different header strategies, 4 different request bodies, and 4 different response formats. And this is the real problem. As soon as your app grows, when you want to switch models, compare providers, optimize costs, or reduce latency, this approach collapses. You are no longer building AI features. You are maintaining provider-specific loop code. Next, we will rebuild the entire flow using a single abstraction, the Vercel AI SDK. Now, let's rebuild the same OpenAI fetch using the AI SDK. This is the old one. And now, as you can see, using the AI SDK, look at this code. First, notice what is missing. There's no endpoint, no manual headers, no request body construction. Instead, we import generate tests from the AI SDK and the OpenAI provider. Then we pass a model reference, OpenAI GPT-5 Nano, and a single simple input, prompt. That's it. Now look at the response. We get tests directly. No parsing, no traversing nested objects. We just log the result. Same outputs as before, but with a fraction of the code and zero provider specific logic. Now let's switch to cloud. I'm running npx tsx fetch using AI SDK slash Anthropic.ts. And here is the interesting part. The code barely changed. We still call generate test. We still pass prompt. The only difference is the model provider. We are importing Anthropic and we are using the model Cloud Haiku 4.5. No new headers, no new request schema, no new response parsing. The response, the exact same shape test. This means switching from OpenAI to cloud is no longer an architectural decision. It is a configuration change. Now let's try Gemini. Once again, the structure of the code stays the same. We import the Google provider, reference the model, and pass the same prompt. Now let's do the same thing with OpenRouter. You will notice something different in this file. The OpenRouter provider is not imported from AI-SDK. That's because OpenRouter is a community-built provider. It's not an official library by the AI SDK team, and this is important to understand. The AI SDK supports both official providers and community providers, as long as they implement the same interface. In this case, we import OpenRouter from OpenRouter slash AI SDK provider. But once again, look at the code. We still call generate test. We still pass a model. We still pass the same prompt and the response exactly the same test. Now, if you are wondering which providers are official and which ones are community maintained, let me show you something. You have to come here to AI-SDK.dev, and then you have to click here on providers. Up here, you will find the official AI SDK providers. And down here, you will find the community providers. Same interface, same developer experience, different ownership, but full compatibility. And that's the beauty of this abstraction. One thing you might have noticed so far in all the previous examples, we never explicitly talk about environment variables, but that doesn't mean they are optional. They are still required. The difference is that the AI SDK already knows which environment variable to look for each official provider. For example, when you use the OpenAI provider, the SDK automatically expects OpenAI underscore API underscore key to exist in your environment. You can see more here in the AI SDK library. If you come here to OpenAI, you will see that the property API key is expecting this environment variable, OpenAI API key. That's why we didn't have to pass it manually before. But what if your API key has a different name? In that case, you can explicitly configure the provider using create OpenAI. in this way. You have to use the function create OpenAI. You have to pass the API key property and also the other name. In this way, you can use another environment variable name. An AI SDK gives you a single abstraction layer, same function calls, same mental model, same output handling, while freely switching models underneath. This means faster experimentation, easier cost optimization, safer migrations to newer models, and less technical debt over time. For real world application, this is not a nice to have, it's mandatory. And with that, we wrap up this video. If you're a JavaScript or TypeScript developer and you want to build AI applications that actually scale, this is the kind of architecture you need from day one. At jsengineer.ai, we don't focus on just using models. We focus on designing systems that can evolve in cost, performance, and quality over time. If this content brought you value, make sure to subscribe and leave a like. Thanks for watching, and I will see you in the next lesson.